Yeah. Hi everyone. Good evening. Welcome back to 360DigiTMG's domain analytics program. The very first day we have discussed about what are the machine learning applications when it comes to healthcare analytics. How are we going to improve healthcare analytics using the machine learning algorithm? And the day two we have discussed about different algorithms we'll be having when it comes to machine learning, like supervised, unsupervised, and how we're going to do the pre-processing. And when it comes to text, when you have unstructured data, that is we have learned in the very third class. What are the structured data, what are the unstructured data, how we going to pre-process. And then we have taken one use case scenario using the unsupervised learning, that is k-means. We have taken k-means algorithm and we have tried to apply that k-means algorithm in case of healthcare analytics using the machine learning, the k-means algorithm. And in that we have predicted the diabetes cases, segregated the different patients, diabetes patient. We have done segregation, and then we have taken KNN algorithm and try to predict the cancer, whether that particular person is case is benign or malignant based on the historical data. And today we will be discussing about decision tree algorithm. It is very one of the popular algorithm when it comes to machine learning. How we going to implement the decision tree algorithm? What is decision tree algorithm? How we using the decision tree we'll be classifying the cases, different classes. How we going to do classification? We'll see in this class. That is a quick recap, whatever the thing that you have discussed in the very first 5 days. First day, it is all about applications. And this next day, we have discussed about machine learning primer. In that, what is supervised, what is unsupervised. We have discussed. On third day, we have done pre-processing. It is on third day. And fourth day, we have taken the unsupervised learning, that is k-means. And we have done diabetic segregation. Patients segregation. That is on fourth day. And fifth day, we have taken KNN algorithm and try to predict. We have applied that KNN algorithm in machine learning and predicted whether that particular case is benign or malignant. So if you haven't watched those videos and if you want to learn about those things, please go back and you can search healthcare analytics. You can go to 360DigiTMG healthcare analytics, and then you will be finding all the first day, second day, third day, fourth today's videos. That is a quick recap, whatever the thing that we have discussed in the last previous classes. So what is a decision tree algorithm? So it is supervised algorithm. Decision tree is a supervised algorithm. That means we will be having labeled data. We'll be having labeled data in our data frame. Labeled data or column you can say, or target column you can say. We'll be having target column when it comes to decision tree. So we can apply this the same decision tree for both classification as well as regression. We can apply the same decision tree algorithm for both classification and regression. In this class, we'll be learning how we're going to apply the classification algorithm, the decision tree classification algorithm, and we'll try one use case scenario. We'll be having one use case, that is TNBC, relapse prediction. TNBC relapse prediction. That means triple negative breast cancer relapse prediction. We'll see what exactly that TNBC is and why we are going for decision tree only. We'll all see when we discuss the use case. So we'll be using the same decision tree for both regression and classification. What exactly is decision tree? When it comes to elements of the decision tree, we'll be having root node. We'll be having root node, branch node, and leaf node. Let's take an example. You are in your house. How exactly will be applying the decision tree algorithm when it comes to data set? We'll see one example. You are in a home. Decision tree is all about whether yes or no. It's a bunch of yes and no, or you can say if else condition ladder. Yes or no ladder only. So first, you are in home. Let's say you want to go sleep, or if you are hungry or not. Hungry, yes. In that case, hungry, no. In that case, you can simply go sleep again. If you are hungry, in that case, do you have some money in your pocket, like 100 rupees or 200 rupees? If yes, go to some restaurant and you can have meal. Go to restaurant. If you don't have money, no, in that case, go and buy some juice, drink, and then go sleep. So this is how normally decision tree works. It is all about questions. Everything split it into different questions. Based on that, we'll be answering those questions and we'll keep moving. Like that, it will each and every point in data set, whichever the data set that we are applying, it will get into the data set and it will split into yes or no cases, and will keep going until it will find the solution. So what exactly is decision tree that you have discussed? How to build a decision tree? We'll see. But what is the greedy algorithm? How are we going to select which feature is best? From where we have to start splitting and all those things we'll see. And we'll try to build a best decision tree. And what is the information again? When it comes to decision tree, it will help us to select the root node, best root node. Where exactly we have to start splitting our data decision tree. That we'll discuss, and we also discuss one business use case. Yeah, in a decision tree, this is a root node. These are decision nodes. Right from that, we will be splitting our tree. And these are final nodes, leaf nodes, you can say. So here, how many decisions we have? How many decisions we can take? 1, 2, 3, 4, 5, 6, something like that. You can take decision. These are all final decisions, you can say. So this is the root node. Root node means wherever you are started splitting. So how do we select whether which node I have to consider? In data frame, you will be having so many inputs. Let's say it is x1, x2, x3, x4, x5, x6, and it is y. So since it is a supervised and it is we are doing the classification, in that case we should have categorical or discrete as a y or target. Target column should be categorical or discrete since we are using the classification case. If it is continuous, in that case you have to go for regression. Since we are going for the classification, so we'll be having yes or no cases or some other categorical 0 or 1, something like that we'll be having since it is a classification. So we'll be having so many features that are input columns. Which one we should consider as a root node? How do we know which one we should consider? For that, we will be having one algorithm called greedy algorithm. And then we'll be calculating the entropy. Using entropy, we'll be calculating the information gain in that greedy algorithm only. Entropy, and we have to calculate the information gain. Based on the information gain, we will be selecting which is the best root node to split. Among all the input features, based on the information gain, we will be selecting which root is the best. So normally this is how the decision tree will be looking like. All the number of options it will be having, the very first one, it will keep splitting. It will keep splitting until you can make a decision. Something like that, you will be, the decision tree will be looking like. Yeah, let's say you have x1, x2, or x3, x4, x5, and you have y. So how do we consider which is the best root node? These are all. I mean, we are considering the input variable only as a root node. But how do we know which is the best root node? Whenever you reach leaf node, means that is decision has been taken. Whenever you reach terminal or leaf node, you can say that decision has been taken. You can simply count the number of terminals. Based on that, you can say these many rules has been formed. Based on number of terminal, you can say the number of rules that to that particular decision tree. So in order to select the root node of that particular tree, we have to go through each and every column. First, we have to do what we have to do. We have to calculate the entropy of the whole data frame. Let's say this is a data set. This is a whole data set you will be having. First, we have to calculate the entropy of the whole data set. And then you have to calculate the entropy of each and every column. Then you have to subtract main entropy, that is entropy before splitting and entropy after splitting. That is only our information gain. So we have to calculate the entropy of whole data set, and then we have to calculate the entropy of each and every single, each and every individual features, and then we can say we have to subtract the main entropy before splitting and after splitting each and every feature, and then wherever you are getting the highest information gain, that is your best root node. So when it comes to decision tree, we can also call. We'll see how exactly we'll be doing that is entropy, how we'll be calculating entropy, and how we calculate the information gain from that particular data frame. We'll be seeing that. But before that, the greedy algorithm. The greedy algorithm is a very basic algorithm to calculate the entropy, and then we can, using that entropy, we can calculate the information gain. Tree structured in a top-down recursive way. Since we are calculating everything in a top-down manner, it is called as a top-down recursive divide and conquer manner. Or you can simply say top-down recursive divide and conquer. So we will be dividing the whole thing, and then we are finalizing the result. So we are dividing based on yes or no cases, and then we are coming up with one inference, or you can say final output. That is why it is called as a divide and conquer manner. So what happens in a greedy algorithm? First, it starts all the training examples are the root. Whichever the input variables will be having, those are the roots first. And attributes are categorical. If we have any categorical, that is fine. In that case, you can split. But if we have continuous? When we have a continuous, you won't be able to use for splitting. In that case, what you have to do, you have to convert all those continuous into discrete values. What is continuous into discrete? We have already seen, right? Whenever you have continuous values, those are, let's say, salary. In salary columns, you have something like 10,500, 50,000, something like that. Whenever you have all the continuous values, and if you want to convert all those into discrete, something like I want to just two categories in whole salary. I'll be having I want just two categories, that is low salary and high salary. Converting the continuous variables into discrete is called discretization. It is called discretization. You can, whenever you have a continuous values, in that case you won't be able to split. In that case, what you have to do? You have to convert those continuous variable into discrete variable. And then we will be splitting. We will be splitting based on questions, whether it is yes or no. Based on that, we will be keep splitting. So what are the, so how long will you keep doing that? How long you will be keep splitting? Until and unless all the samples for the given node belong to the same class. That means, let's say you have categories, that by category, you have yes, no, and that you are keep splitting until and unless whenever you split, let's say here some feature, or you can say some data, until and unless it will become same class. In here, you should be having all S class or all no class. Until and unless you will be having same class on the branch node, or you will be having just one class, any one class, whether it is S class, or whether it is no class, any one class. You should, whenever there is all homogeneous cases, you can say all homogeneous, or you'll be having just one class. You don't, then you can stop splitting at that particular point. All samples for the given node belong to the same class, whether it is S class or no class, any class, but it should be homogeneous. Then you can stop, or there are no remaining attributes for the further partitioning. Only one. Only one. In that case, you can simply stop there. There are no samples left. In that case, you can stop. So in order to calculate the information gain of that particular column or feature, first we have to calculate the entropy. So what is entropy? Entropy is a measure of disorder or measure of impurity. Entropy is a measure of disorder or measure of impurity. Let's say you have one feature and you have split it here. Here you have S case and no case. S case. S, no, no. In this case, will you able to will you able to take decisions? Here we have some attribute. Will you able to take decisions here? No, you won't be able to take decision. If it is in the same homogeneous case, if all are S, in that case you can able to take a decision. If all are no, at least in that case you can take a decision. But if it is a mixture of both, in that case you won't be able to take any decisions. You won't be able to take any decision. In that case, we can say we have an impurity. You won't be able to take a decision. That is, in that case, you can say we have an impurity. Entropy itself, measure of impurity. How do we calculate the measure of impurity? We'll find entropy of the output variable for a set of training instances. So first we will be calculating, like I said earlier. So first we will be calculating for whole data set, whatever the data set will be having. For that, we will be calculating entropy. That is entropy before splitting, we can say entropy before splitting. And then what we can do? We can apply the same entropy on each and every column. Right after splitting, we can apply each and every column. In that case, if output value split 50-50%, it is the highest impurity. Let's say you have splitted data. In that, you have 5 columns. Let's say you have 4. In that case, S is 2 times, no 2 times. You have 4. In that, you have SS and no 2 times. That means S class is 50%, no class is 50 times. In this case, you won't be able to take any decisions. In this case, you won't be able to take any decision. It is 50-50. It is like 50-50 probability. You won't be able to take any decisions. You are not sure about anything. In that case, only you will be having the highest impurity. It is highest impurity. Whenever you have done split and the classes are 50-50. Whenever the classes are 50-50, in that case, it is called highest impurity. Highest impurity. Opposite to that, if output is 0, said to be pure. When you have only one cases, any one, S, no. Now, in that case, you can directly take a decision. Whenever you do split, and you have a classes of S and no, any one, in that case, you don't have any impurity. You can directly take a decision. This is S case and this is no case. In that case, you can easily take a decision. And when you have output split is 25-75%. yes, you can say 25%, and no, you can say 75%. That is 4 cases. Let's say these are 4 cases. Yes, okay, yes, 25%, right? Then case no, no. It is 25, 75%. In that case, we'll be having standard value, that is 0.81. Impurity is 0.81. Somehow you said that like yeah, we have no cases more. In that case, you can say yeah. You can at least you can take decision. We'll be having majority of no. In that case, it may be no, something like that you can take. That is why here said to be pure, and entropy is about 0.8%, 0.811%. So the information gain, what is the information gain? See, maximum, you have to, whenever you are doing splitting and you are able to capture maximum information, that means most of the homogeneity cases you are finding. Homogeneity means whether it is just yes or whether it is just no. Wherever you are getting the maximum, you have, let's say you have 5 inputs that are 5 roots, x1, x2, x3, x4 and x5. Whenever you are doing the split, you have to, in order to calculate the entropy, you have to calculate for each and every input. You have to split at each and every node. These are the root nodes only. These are the only root nodes. You have to do multiple iteration for each and every thing. Then only you will come to know which one is having the highest information, which has the highest information gain. So whenever you do split, and you are forming the least rules, and you are getting the maximum information. What is a decision tree? Whenever, what is the best decision tree? You have to ask less questions. You have to ask less questions, and you have to get answer maximum information. You have to get maximum information. You have to get maximum information. That is your best tree. That is your best. You have to ask less questions, but you have to get the maximum information out of those questions. So whenever you form, using the different the columns, the features you have, whenever you use each and every root node, and you will try to form, you try to split and try to calculate the entropy. In that case, you will be getting different rules. For x1, you have something like leaf nodes are about 11, and x2, if you are getting leaf nodes about 12. In x3, you are getting just 5. Let's say that. Let's say you have rules for x1, x2, and x3. In this case, 11, 12, 15. See, the same rules, and the classification is done same, right? The classification is same, but rules are different. In that case, which tree you will be considering as the best one? So here we are asking very less questions, but we are getting the maximum information. All the classification are done based on just 5 rules. Just 5 rules, and all the classification is done. But here, 11 rules, the same classification is done. Here, 12 rules will be having the same classification. So whenever you have a less rules and maximum information you are getting, in that case, that is your best root node. You can decide that like that too, or you can calculate the entropy of each and every column and entropy of the data frame, and then you can subtract each and every time for all the different features or different input variables. Then you will be able to get what exactly the information gain is. So that is how you will be calculating the information gain. So here, this is a heuristic approach. You can say heuristic approach. So how you will be calculating the information gain? First, this is the formula for information gain. Probability of I log 2. So what is it? Here I is the classes. In data set, whatever the data set you are using, you will be having classes now. S case or no case, something like that, 0 cases or 1 case. These are all classes. So whichever the classes you will be having, for that sigma summation of all. Summation. You have to take care of each and every class. Say Pi, that is S class, log 2 PS class plus P no class log 2 P no class. So this is your entropy. Why we are giving as a negative? Because it is a measure of impurity. That is why we are giving just negative, but normally that value won't be considered as a negative. We are just representing as a negative, but it is not negative. So this is how you will be calculating for entropy for whole data set, the main data set, you can say main data set. Entropy for main data set. Then what we will be doing, in order to select the root node, best root node, in order to select best root node, what we have to do? We have to calculate the information gain, right? So what is the information gain? Information gain, entropy before split, entropy after split. So what is after split? Here you will be having the right after splitting, you will be having some cases, to total number of cases, classes, you can say. The probability of whatever the you will be having right after splitting to the total probability. Whenever you do split based on the root nodes, those cases you will be having probability and the total number of whichever the main data frame will be having, that probability into entropy of that particular case or any attribute that you are taking. Finally, this is the information gain will be getting. This is information gain before splitting. Sorry, you can say entropy of before splitting and entropy after splitting. If you subtract both, you will be getting some information gain. Like that, let's say if you have 2, 3, 4, x4, x5. If you have this features, you will be getting entropy for each and everything. Each and every class will be getting entropy. Wherever entropy is higher, wherever entropy is the highest, that node is root node. Will be considering as a root node. That means wherever information gain is high, in that case, less number of rules will be found. Less number of rules. So you'll be having less number of rules, so that you can start splitting your tree from that particular point. Whenever the information gain is high, in that case, you will be forming less rules. So now you can consider that tree as a root node and you can start splitting. Yeah. Again, this pretty much same. Again, whenever it comes to supervise, you have to train your data, train your model. Here we are taking the decision tree. So decision tree algorithm as your model. Then we are training the decision tree based on trained data set, and then we're testing on test data set, and then we'll calculate the accuracy, and if it is then we'll check whether it is overfitting or underfitting. Based on that, we will be doing the hyperparameter tuning. So in decision tree, we'll be having so many hyperparameter tunings, And see, when it comes to disadvantages of decision tree, what are the disadvantages of decision tree? Decision tree disadvantages. It is prone to overfitting. Prone to overfitting. What is overfitting? When training accuracy is high, and testing accuracy is, in that case, it is called as a overfitting. Why it is overfitting? Because it will go each and every data point. It will go each and every data point. Then it will take decision, right? It will go through each and every data point. In that case, there is a possibility it can learn everything. So it will be having idea for everything. That is why it is called prone to overfitting. It is prone to overfitting. So how we can avoid this? How can we avoid the overfitting? We'll be having two, in order to regularize that. We'll be having other regularized techniques as well. But here in decision tree, we'll be having pre-pruning and post-pruning. We'll be having pre-pruning and post-pruning. Based using those, you can avoid that overfitting issue. So here we'll be taking one use case. It is very base. We'll be building one base algorithm, very basic one. Base model, you can say, very base model, and then you can do some hyperparameter techniques, and you can improve the accuracy of that particular model. But here will be well, let's look at the very basic model. So this is all about decision tree. How we are selecting the root node? First, we have to calculate the entropy of that particular node. First, data frame. Let's say it is a data frame. You have to, which one we are considering as a target column? Here we are considering the relapse. Here we are considering the relapse one. Based on that, you have to calculate the entropy. For this, you have to calculate entropy first. Entropy. Then whichever columns you will be having, whichever the column you will be having as a numerical. That all you have to convert it to categorical or discrete, you can say. You have to consider each and every column, and you have to calculate the information again of each and every column. First, you have to calculate the data frame information entropy. Then you have to calculate each and every column entropy, and then you have to subtract entropy after before splitting, entropy after splitting up each and everything. Then you can start splitting wherever information is high. So here we are taking one use case scenario. What is it? Triple negative breast cancer. Triple negative breast cancer relapse prediction. TNBC relapse prediction. What is relapse? So what happens in triple negative breast cancer? Even though that illness is cured, there is a possibility that it can relapse again after some time. Relapse means it can reoccur, you can say. Even though that particular illness is cured, there is a possibility that it can reoccur again. So based on the patient history, whatever the patient history will be having, based on patient history, we have to predict that whether particular patient is it gonna relapse or not. Whatever the patient will be taking, that cancer TNBC for that particular person. Is it is it going to relapse or not? We have to predict based on his patient history, medical history, based on medical history. So we'll be having data set previously whomever occur and their medical history will be available. Based on that, we have to predict whether based on that we have to predict for new people, I mean new patient, whether for these people is it going to relapse or not. We'll see that. So here, what are the columns we'll be having? Age, that is the index, very first one. HPE, stage, tumor size, surgery level, and relapse time, relapse. Whether this is our target column, chemo given initially or not, treatment given relapse, on relapse, outcome, time, survival event. It is a very fast data set. I haven't, it is just a screenshot of the very first data set. You can see we have so many NaN values, nil values. So you will see how what we are going to do, how we can clean this data and all in a minute. But this is our data set. For that, after that, what we have to do? We have to do some EDA. Right after doing this EDA, that I have realized that most of the cases they are getting. Most of the cases are AGCT only. This is a type of in TNBC only. It is one more type. In TNBC, there are different types like AGCT, SCST, and JGCT, and secreting tumor. Something like that. We have different. From the count versus HPE plot, it is a column, HPE column. We'll see in a minute. Clearly see that AGCT cases are more common compared to the other cases. Just by looking at the plot, you can say that AGCT cases are more common compared to any other cases. These are the more common cases compared to other. From this, what are the things that you can infer? Whatever I can infer, I've wrote down, and if you have some others, you can simply note it down. From the count versus HPE plot, we can clearly see that AGCT cases are more common compared to other cases. I think the very second one only. Same. Okay. From the surgery relapse group plot, we can say that the relapse case high. Right after the doing recovery, relapse cases high among the people who did not complete the surgery. Whoever not completed the surgery, for them the relapse cases are a bit high compared to other people. These are the EDA. Right after going through the this data set, you can simply do exploratory data analysis. That is EDA. You can do EDA and you can come up with inferences just by observing the data. We'll see coding. I mean, how we gonna do the prediction using the decision tree algorithm. Right after that, you will be getting something like this is final. How decision tree, how the decisions are taken. First, it will check all the data frame that we'll be having. Then it will convert split into two root node based on root node, which is the best root node. It will check. Based on that, it will split. It will keep splitting. Here, how many roots we have? Just checking just by the leaf node. Just by going through the leaf node, you can say these many rules are formed. This is one leaf node, 2, 3, 4, 5, and 6. You can say you have 6 rules. This is how the decision tree will be looking like right after doing all the predictions. We'll see coding how we can perform decision and this. Yeah. So in order to do that, first we have to import the pandas, and then we have to numpy. Then we have to, for visualization, I'm taking the SNS, that is Seaborn library, that we will be using for advanced visualization. And then we have matplotlib pipe, matplotlib. You can use any one of those, but I'm importing both. Why we are importing the pandas? Of course, in order to do the data manipulation. If you want to change anything, in that case, you can be doing just using the pandas only. And then numpy for mathematical calculation, I'm using the numpy. Seaborn for visualization. So this is our data set, TNBC survival. This is our data set. It is very base model, guys. Base model. And I'll just show you how you're going to apply the decision tree algorithm on data set. If you want, you can simply go to public sources like Kaggle and GitHub, and you can take any data set and you can work on it. But this is a very basic data set. You can see here, this is our data. Whenever you use tail is equal to 5, last five data points will be returned. So here I'm dropping the survival and event because these are pretty much same as relapse. So I'm not considering those, and I'm simply dropping survival and relapse. Whenever you do describe, what happens? The mean, median, standard deviation, whatever the max value, whatever the minimum values will be displayed. Shape 34 is a very small data set. Since it is a base model, I'm performing that. But if you want, you can take large data sets. So what are the columns we'll be having? What kind of data types these are holding? That you can see: age, tumor size, tumor size, stage, surgery level, relapse, and all those things. When you see unique values, what are the different types you will be having in each feature that you can see? Mean, median, mode. So I'm checking whether we have any outliers or not. So obviously we don't have any outliers. You can see the box plot. And then I've done some EDA just to do some, I can find anything interesting from the data. So whatever the inferences that I got, I've already presented in your PPT. I've pasted those in PPT. You can check out. So these are the EDA, whatever the EDA that we can do. So whenever you do EDA, you will be finding some interesting insights. So that based on that, you can do improvement, or you can do according to that, you can do some changes in our model. And then you will know which features you want to take, whether you want to take or not, something like that you can find. And then I'm checking the correlation matrix, whether we have any correlation between all that. Seems like we don't have any correlation in the data at all. And we are checking whether that particular age column we'll be having, is it normal or not? Seems like it is not completely normal, but similar. I mean, kind of okay. You can take it since it is a very large, very small data set. So we don't need to worry about it. We'll just check how we're going to apply the decision tree algorithm. So I'm finding out the correlation between all the columns, age, surgery level. It is a heat map. It will show you all the correlation between each and every column that you are taking. So here we'll be having strong, negative correlation when it comes to age and surgery level. A good correlation, you can say, whether it is positive or negative, it doesn't matter. You have to take positive correlation or negative correlation. Both are fine, but you should have at least some correlation, whether it is positive or negative, it is fine, but you should have a correlation. age and outcome time as not that, 0.098 it is. So we don't have that much correlation. These are fine. Here we'll be having the same surgery level, and so we don't really have any correlation in between, that much correlation in between input columns, so we can go ahead with model. If we have any correlation in between the columns only, in that case we might get into the collinearity issue. If we have a correlation in between output variable and input variable, that is fine. But if you have correlation between the input variables only, that could be a problem. You might get into the collinearity issue. So in that case, you can do feature engineering, or you can simply take any one of those columns. So whichever columns I'll be having, that is categorical, I'm converting into numerical, so that I can feed to the model. Right after doing the heat map, it doesn't require, actually you don't need to do this heat map since we have already done. Anyway, these are numbers only, so even though you do the heat map, it doesn't make any sense. Now we are taking relapse column into output, and the rest are in input features. So age, HP, stage, tumor size, surgery level, relapse time, chemo given initially, treatment, all of these are taking into input features. And I'm taking relapse, that is the output, that is a target column. I'm taking relapse in target column. And then we are splitting into train test. Okay. So in output, what we have? All the relapse 0, 1, 0, 1, whether it is going to relapse or not, whether it is going to relapse. Then we are splitting into train test. We're splitting into train test, X train, X test, Y train, Y test. That is 0.33. We are given test size is equal to 0.33. In that case, train size will be 67, 0.67. Since we have a very small data set, we are giving as a 33. Normally, we'll be giving just 20, but since I have a small data set, I'm just giving 33. Then you can simply import the decision tree algorithm, sklearn import decision tree algorithm, and then you can fit whatever the thing that you have taken, those X train and Y train, you can simply split and you can classify. In that case, we have 1, 1. So it is obviously overfitting model. It is obviously overfitting model. In that case, what you have to do? You have to use hyperparameters. Hyperparameters, or you can use pre-pruning, post-pruning. You can use pre-pruning and post-pruning, and you can improve the model. That you can do using the hyperparameter tunings, or you can do you can use pre-pruning and post-pruning. This is the one use case, guys. Obviously, it is very base model, basic model. You can say basic model. We haven't done any hyperparameter tunings and all. It is just a basic model, and if you want, you can simply go for. You'll be having different hyperparameters like max depth, number of splits you want. You can go with different hyperparameter tunings, since we have so many hyperparameter tunings in comes to decision tree, and you can apply and you can try to tune the algorithm and try to increase the accuracy. Whenever you have like near equal test accuracy and train accuracy, near equal, like 80, not more than 1% difference. In that case, you can say that train and test are the best fit. So this is all about a decision tree and how we gonna decide which route is the best route. Based on information gain, we will be deciding which route is the best node route, and then we'll be taking that node as a root node, and then we are splitting the tree based on the information gain. First, we have to calculate the entropy, and then you have to entropy after split. You have to take entropy before split and subtract it. In that case, we will be getting information gain. Based on information gain, we are selecting the root node of that. Yeah, that is all for the decision tree, guys, and how we're going to apply the decision tree algorithm when it comes to healthcare analytics. And one more thing, forgot to mention that confusion matrix. Whenever you're working on healthcare data, you should see how many classes you have. Classes, it is classified perfectly, and how many classes it is misclassified. Based on that only we'll be deciding the accuracy. So please take care of the false negative cases. So it could be detrimental when it comes to false negative cases. False negative cases means even though that particular having the relapse, relapse can happen, but you are saying no, relapse won't happen for you. In that case, what happens? He might get relaxed. In that case, he won't be able to know until he reaches the last stage. So it can be detrimental when it comes to false negative cases. Please try to decrease as many false negative cases as much, even though your accuracy is not the best. But if you have less false negative cases, that could be the best model. Don't just concentrate on accuracy. Please do concentrate on the false negative cases, especially when it comes to life sciences and healthcare analytics. Yeah, this is all about today's, guys. What is the decision tree and their application when it comes to healthcare analytics? And if you want to, start your data science career from July 11th, in between 6:30 to 7:30, there will be Python sessions will be started. Will be starting in our 360DG channel, 360DigiTMG. 360DigiTMG channel. You can join, and you can Python session will be starting in between 6:30 to 7:30. You can simply join, and you can start your data science career. And yeah, this is all for today, guys. And yeah, I hope you guys learned something, and we'll see you in the next class, and have a nice day.